Hello guys, today we are going to see electrochemistry problems and tricks. Welcome to my channel Winchem. Those who are not subscribe my channel, subscribe it. We'll see the problems one by one. The first problem, write the cell reaction for the cell representation. This is the cell representation is there, so we need to write the cell reaction for this. Two reactions are there. See here, cell representation is there. Here this chromium 2 chromium 3 plus is an oxidation. This tin 2 plus 2 tin is reduction. Okay, reduction takes place oxidation. Always first you need to write the oxidation reaction and then reduction reaction, that is anode reaction and then cathode reaction. This is the cell representation method. We need to write this as a cell reaction. So first one is the metal and which we are going to react, this one, these two should be in the reactant side and these two should be in the product side. That is the way we need to write the cell reaction. Okay, the first one in the before the slash and here the first one before the slash, both we need to write it on the reactant side. We'll see the answer. Okay, see the chromium react with tin 2 plus and it gives chromium 3 plus and tin. Why? The chromium will give 3 electrons and it becomes 3 plus. Okay, here it's giving 3 electrons. So but here it's taking a 2 electrons. Okay, here it's showing as a 2 plus. It's taken as a 2 electrons, like that it's showing, and it becomes 2. So we need to balance the equation. That's why here 3 electrons means immediately you put 3 over here and after that you just balance it. It becomes 6 electrons. Then we need to make it this also 6, here also 6, here also 6. It releases the 6 electrons and it recover the 6 electrons. Okay, accept the 6 electrons. So this is also, it should be 6. So here you put 2 over here, so it becomes also 6 electrons and this is also 6. So it will be balanced accordingly. So according to that we need to balance it. Okay, the next one is lead 2 plus, iron 3 plus 2, iron 2 plus. See here also the first one and here the anode first metal and the cathode first ion, both should be in the reactant and the product should be in the product side. This is a reduction takes place, here the oxidation takes place. Always the first cell representation, first you need to write the oxidation and then the reduction reaction, that is anode and then cathode. Okay, see here lead plus Fe3 plus and then lead 2 plus and Fe2 plus. After writing all like this, you just balance the reaction. That is always easy. So here 2 electrons is given. Okay, it releases here oxidation, it gives 2 electrons and it becomes 2 plus this metal. Okay, so if 2 electron is accepts means here see the answer Fe3 plus to Fe2 plus. Here it reduces only 1 electron. Okay, reduction takes place with 1 electron only, so it accepts only 1 electron. So here we need to put 2. Here 2 electrons is releases, so we need to accept 2 electrons for this. That's why we are putting 2. You just observe what is happening over the reaction, full reaction. Accordingly you need to balance the ions, then only you can able to balance it properly. The basic understanding should be necessary for this. Okay, and the next, write cell representation for the cell reaction. We need to write the cell representation the same way. First what we need to write it, we need to write the oxidation and then reduction. What is the oxidation? Magnesium 2 plus oxidation, nickel 2 plus 2 nickel is reduction. So write it accordingly. So oxidation is magnesium to magnesium 2 plus, put 2 slash and then write reduction. Reduction is Na2 plus 2 Na2 plus 2 Na. First always you need to write the reduction and then oxidation and then reduction. In the same way here, magnesium to magnesium 2 plus is oxidation. How I am saying this is oxidation, if you see the element is always the oxidation status 0. Here 0 to 2 plus, the oxidation status increases. That's why its oxidation takes place. Here the oxidation is reduction, reducing 3 plus to 0. If it is reducing, if it is reducing means that is reduction takes place. If the oxidation status increases, then it's oxidation. Oxidation takes place. Okay. Accordingly, we need to understand it. We need to take it into the account. So magnesium 2 plus, first we need to write it. Double slashes and Al3 plus and Al. The next sum is, these are all the basic understanding, that's why I am saying here. The next one, depict the galvanic cell in which the reaction, which of the electrode is negatively charged. Which one is having negatively charged? The carrier of the current in the cell, which is the carrier of the current. Third, individual reaction at each electrode. Each electrode individual reactions they are asking. That is half reactions we need to write. This is the cell representation. First oxidation and then reduction. Okay, if you know this, then only you can able to do the problems over here. That's why I'm including these two problems over here in the beginning itself. See, a zinc electrode is a negatively charged. So anode is a negatively charged. This is a cathode. First anode, another one is cathode. See, this is the anode and this is the cathode. So anode is releasing the electrons towards the cathode. Okay, and current is in opposite ways. Whenever the electron is going in the way, you know, the current is always in the opposite of the electron. So the current will be in the from cathode to anode. See, the electron flow from anode to cathode and the current flow from cathode to anode. It's always in the reverse manner. So that's why the first one is zinc is the negatively charged, first one. Second one, which is the current carrier? Current carrier is which one? Current carrier is from cathode to anode. Which is the cathode? Silver. Silver to zinc. And then third one is individual half cell reactions. So every redox reaction is having a oxidation and the reduction reaction. That's why we call it as a redox reaction. Okay, every reaction is having this oxidation and plus reduction. That's why we need to write half reactions: oxidation half reactions, reduction half reactions. So zinc to zinc 2 plus is oxidation and reduction is Ag plus. It accepts electrons and it becomes Ag. It's not a completely balanced equation. If it is balanced, means it should be 2 electrons and 2 Ag plus it becomes 2 Ag have to come. Okay, it's not a balanced equation, just half reaction as written. Okay, we'll see the next step. This is the 5 important tricks to remember. We are going to see some of the sums regarding to this only. The first 2 sums are only basic sums. In the upcoming sums, you know, these are all very important. We need to keep it in our mind. This is the first 5 important tricks we need to keep it in your mind. First one, what is that? Standard reduction potential is there. These are all the standard reduction potential. If the standard reduction potential is high, it easily undergoes a reduction and it is called as an oxidizing agent or oxidizing power. Okay, that is the first one. The reverse of that is whenever it is having a low reduction potential, okay, standard reduction potential, that easily undergoes oxidation and it is called as a reducing agent or power. That is the second trick. The third trick is whenever is having the low reduction potential, you know, that metals, most of this here, you know, metals only will be there. And the group 1 and 2 metals will be there. These metals easily form a positive ion. It's an oxidation takes place, you know, if oxidation takes place at metal, it goes to plus charge. So electropositive charge. So it becomes positive easily and it is more reactive and it is called as a more reactive. Okay. So wherever the oxidation takes place and these sides are more reactive. That is the third trick we need to keep it. And the fourth one, every reaction is having every redox reaction is having half oxidation and half reduction is taking place. In this, if the reduction half reaction having an electrode potential, you know, that should be high. If it is high, then the reaction is spontaneous. In this redox reaction, if the reduction half reaction is less than that of the oxidation, then it is non-spontaneous. Okay, the reduction half reaction, it should be high electrode potential. If it is less, then it is non-spontaneous. If it is high, and it is a spontaneous reaction. The example we will see. Here I said, you know, this is the best oxidizing agent. This 2.57 is a fluorine and this is the lithium. This is the best oxidizing agent. That is, reduction takes place over here. That's why this is the best oxidizing agent. This is the highest one. And here lithium, it's a reducing agent. What is happening here? Oxidation is happening. That's why it's a lowest standard reduction potential. Okay, this is the example. And for the reduction of reactions, spontaneous reaction is there. No? For that, this is an example. Copper react with the ferrous sulfate and its copper sulfate and iron is forming. Okay, see here, the copper undergoes the oxidation and iron is undergoes the reduction. The copper oxidation, the electrode potential is 0.34 and the reduction ferrous ion potential is minus 0.44. This is the reduction reaction, but its electrode potential is less. If the reduction takes place and its potential is less than that of the oxidation, then it is non-spontaneous reaction. This is an example for non-spontaneous reaction. This is the 5 tricks which we need to keep it in our mind. See, this is the electrochemical series. Okay, the first one is why we are saying is a reduction potential. Okay, these are all standard reduction potential. See here, reduction is taking place everywhere. The electrons are accepting and that goes for the ions. Okay, so it is a reduction reaction. So it is a standard reduction potential. Otherwise we call it as. Okay, we will see the sum. Third sum. Calculate the cell potential for this reaction. Cell potential they are asking. This is the reaction. We need to write the cell potential. What is the data given here? Iodine electrode potential is given and iron electrode potential is given. Another one is magnesium reduction potential is given and they are asking the reverse of that. This is the reduction reaction For what is the electrode potential for the oxidation reaction they are asking. How to do it? We will see. The electrode potential formula we know very well. Eanode cell, that is cell potential, sorry. Here cell potential they are asking. Cell potential Eanode cell, which is equal to Eanode of cathode minus Eanode of anode. Always we need to write the cathode over here. Whenever we are writing the cell representation, first we need to write the oxidation, but here if you write the cell potential equation, that cell potential formula, first we need to write the reduction, that is cathode. Cathode is always, reduction takes place in cathode, you know. First you need to write the cathode and then anode. Anode should be at the last, that is oxidation should be at the last. Okay, so what is the cathode over here? See the first one, which is the cathode. 0.77 is the cathode. Reduction is taking place here. 3 plus 2, 2 plus, there is reduction. So write this one, minus of anode. Anode is this one, minus reaction. So if minus and minus is plus. So this is the value for Eanode of A section. And the next one for B, magnesium, the reduction takes place. The reduction takes place, they are asking oxidation of this what? If the reduction potential is there, the same metal, the oxidation is given without any change in the electrons, just you change the sign of this and you put the value. That is the value for this. If it is a negative, put the positive. If it is a positive, then put the negative. This is the value for the negative and the oxidation and reduction electrode potential. Okay, this we need to, that's why I included this as a problem. And the fourth one, a galvanic cell is represented by like this. Galvanic cell is represented zinc and bromine. If the standard cell potential is found to be like this, calculate the standard reduction potential of bromine couple. Given that zinc electrode potential is given. Okay, standard electrode potential of zinc is given, and they are asking about bromine. And cell potential is also given. Okay, Eanode of the cell, we know the formula already. Eanode of cell is equal to cathode minus anode. What is given here? Eanode of the cell, zinc given. Eanode of the cell is given. You need to add over here, and bromine bromine we need to find over here. That is the couple they are asking. Bromine we need to find. Substitute this value. Bromine we need to find. What is the value? Then we will get it. Bromine, which is equal to 1.85. This minus 0.76. So what is the value over here? 1.097. Okay, this is the value of bromine couple. See the answer. Which one is the answer? C. Answer C is the answer for this question. Then the standard electrode potential of potassium is given. Potassium, silver, mercury, magnesium, chromium, everything is given. Arrange these metals in the order of reducing power. What we need to see order of reducing power means, that is reducing agent, according to the reducing agent. Reducing agent means what is that? Oxidation takes place. If the oxidation takes place means what is the value? The electrode reduction potential should be very low. So which is the very low value? That you need to write it first. Okay, which is the very low value in this case? Very low is minus 2.93. Negative, no, negative means in negative bigger value is the lower value. So minus 2.93 is first, and then minus 2.37, and then which value? Minus 0.74 value, and then plus we need to come to the plus is 0.87 and then 0.979. See the answer now. As I said, the trick 2, that is low standard reduction potential is always oxidation, that is a reducing agent, as I said now. So lower reduction potential shows more reducing power. Okay, so which is that? Potassium first, and then magnesium, and then chromium, and then silver, and then lastly mercury. Okay, this is the way we need to write it. The next one, see here, some of the electrode potential is given. Arrange these in the order of oxidizing power. Oxidizing power means the trick 1. Oxidation power means that is oxidizing agent. Oxidizing agent is what is happening here. Reduction is happening. If reduction is happening means the electrode potential should be high standard reduction potential. Okay, high standard reduction potential. Which is having high standard electrode reduction potential. High means in the positive it should be high. So 1.42. 1.42 is bigger one. That is AU. AU is bigger. And then gold, chlorine, and bromine, and then iodine. Okay, accordingly we need to finalize it. The answer for this is this one. This is the answer. So what is the answer for both? C is the answer. See, this is the potassium and this is one, and here this one is the bigger one. So reversely, I have written reversely, so you have to check this one. Answer is C. Sixth one, find out the following reactions. This is a spontaneous reaction. or not. Which is this reaction is spontaneous or not, we need to find out. See, bromine electrode potential is given and gold is also given. If the reaction is spontaneous or not, how to find out the reaction is spontaneous or not? Whether the reduction potential of the half cell reaction of reduction is higher means then that is spontaneous reaction. See, which one is oxidation? This one is reduction. This is oxidation. Okay, here 3 plus 2 0. Here this is oxidation. This is oxidation. Minus 2 0. Minus 1 to 0 is oxidation. This is reduction. So this oxidation is having how much value? 1.08. This one is having 1.42. This is more. So reduction is having more. So reduction half reaction which is having high standard reduction potential, then the oxidation, the reaction is spontaneous reaction. The reaction is spontaneous reaction. What is the answer? Spontaneous reaction. The next one, write the order of reactivity of the metals. Metals are given and the order of reactivity they asked. What is the trick for? As I said, if it is a low reduction potential, it's easily undergo the electropositive charge. So low standard reduction potential, more reactive. When the reduction potential is low, it is having higher tendency of forming a positive ion, electropositive ion. So the reactivity is also good. In this case, lithium is more, and then potassium, and then calcium, and then magnesium, sodium, and aluminum. So accordingly, we need to order it. And for the B, write the order of the reducing power. The reducing power is, as I said earlier, reducing agent. If the reducing agent means oxidation takes place, oxidation means lower value. Lower value, metals are also having lower value. The first metal is lithium, and then we will say sodium, magnesium, zinc, iron, nickel, copper, and then silver. Okay, this is the way we need to write it. Order. The answer for this is A. Is the answer. Next is find out the redox electrode potential of the iron if ferrous ion is this and ferric ion is this one. Okay, some of the ferrous and ferric ion is given. What they are asking? Redox electrode potential. Eanode of the ion is also given. The reduction ion is also given. Okay, now we need to find out the, first we will write the reaction. Okay, what is the half reaction? Reduction reaction. Fe3 plus 2, Fe2 plus. So how much electrons is accepting? 1 electron is accepting and it becomes 2 plus. Okay, what is the values given over here? Fe3 plus 2, ion of electrode of Fe3 plus 2 plus is given, and then ferrous and ferric is given. Ferrous is 0. Ferrous is Ferrous is 0.2 and ferric is 0.04. Okay, both are given. So we need to substitute the concentration of ferrous and ferric in this equation. What is the equation? This is the formula. Here Ecell will be there. What is the Ecell? The reduction takes place. Eanode of the Ecell potential is this reduction of ion, and 0.059 n log Fe3 plus by log Fe2 plus. The n is number of electrons. Here how many electrons accepted? Only 1 electron. So in the n place we need to write 1. So Fe3 plus of Eanode cell is given. Okay, a cell potential. This is the cell potential. Eanode of this one is 0.77. 77 is given plus 0.059 divided by 1 log Fe3 plus is also given 0.04 divided by 0.2. Okay, always first we need to write here Fe3 plus and then Fe2 plus, the reduction reaction, like that only you need to write Fe3 plus and then Fu2 plus, like that you have to write. Okay. If you change this negative, this charge will be, we need to change. If you change these two, you can change this negative value as a negative value. Okay, here if you write like this, you need to write in this way only. 0.77 plus 0.59, and if you divide it log 0.2 we will get it. So log 2 is equal to minus of 0.699. I have mentioned over here. So minus you inserted over here. So if you multiply these two, minus of 0.412, if you subtract it, you will get 0.72 as answer. So what is the final answer? So final answer is B. Okay, 0.73. And the ninth sum, determine the Ecell based on Nernst equation. Ecell we need to write based on the Nernst equation. Already they said the Nernst equation also. This is the cell representation as given. With the help of a cell representation, you should know how to write the cell reaction. Then only it's easy to write the find out the answer. Okay, what is given? Eanode of the cell potential as given, and Eanode of magnesium 2 plus magnesium is also given. So Eanode of cell potential is E naught of cell, which is equal to E naught cathode minus E naught of anode. E cell is equal to what they are given, electrode of aluminum and magnesium is given. Electrode of aluminum and magnesium, you substitute, you will find the cell potential. Cell potential we will get it. With the help of the cell potential only, we can include the Nernst equation. Okay, there is no cell potential as given over here. So E cell is equal to, they are asking E cell. E cell is equal to E naught of cell, this is 0.71 plus 0.059 divided by n. How many electrons? How many electrons? How to find it? If you know the reaction, how to write it, then only you can able to find out. I'll tell you easy way. It's very easy. First we need to write this one and this one in the reactant side, and these two after the slash whatever is there, that should be in the product side. First write as it is, then you see that which is oxidation, this is the oxidation takes place. How many electrons? Magnesium, it becomes 2 plus, so 2 electron is given. So 2 electron is given, but here what is there? 3 plus electron is there, 3 plus electrons, and it becomes 0 electrons. So if it accepts 3 electrons, how it accepts 3 electrons? Actually it gives 2 electrons only. How it accepts 3 electrons? It is not possible. So what we need to do, you need to do this 2 electron as here, put 2 over here, then balance it. It becomes 3. If this is 6, the 3 2s are 6. If this is 6 electrons, it accepts 6 electrons, means how it will accept 6 electrons? If it gives 6 electrons only, it can accept 6 electrons. So this also you need to make it as a 6. So make it 3. So 3 2s are 6. So overall, this magnesium gives 6 electrons to this, and it accepts 6 electrons, and it becomes to Al. Okay, according to that you have to write it. First understanding, basic understanding is very important for writing the redox reactions. Okay. So here n is equal to 6. So 0.71, 0.059 divided by n is equal to 6 log of Al3 plus, that is given already over here, concentration of this and this. Whatever the in bracket, whatever is given, this is the concentration of this ion. Okay. The concentration of Al3 plus is, what is that? 0.03, and the concentration of magnesium 2 plus is first reduction and then oxidation. You have to write it. Subtract it, log of 0.52, which is equal to 1.716. So if you multiply with this, divide it and multiply with this, you will get 0.702. This is the answer. So what is the answer? Answer is C. The next sum is, find out the equilibrium constant for the cell reaction. This is the equilibrium constant reaction, that is K. What is the equation for that? The equation is E cell, which is equal to 0.059 divided by n log K. This is the equation. So we need to find the log K. Log K means at least we should know E naught of the cell. E naught of the cell is given? No, not yet given. Only electrode potential of zinc and copper is given. So if you know the E naught of the cell, then only you can able to find out the log K, equilibrium constant. So for with the help of the electrode potential of zinc and copper, that is anode and cathode, we can able to find out the E naught, cell potential, so E naught of the cell. So E cell potential, which is equal to cathode minus anode. Which is cathode, which is anode? This is the oxidation reaction, this is the reduction reaction. Reduction reaction is cathode. Okay, always the value will be higher. So this is the cathode minus of anode. Sorry, here the value I mentioned is wrong, so I need to change the value. Okay, here the cathode will be, this is the value of 34. By mistake I have mentioned over here, so I will change over the here itself. This is the value of, okay, this is the value of 0.34. Okay, 0.34 minus of minus 0.37. Okay, here the minus of 0.037. So what will be the value? 1.1 V. This is the E cell of the value. If you substitute this value in this place, and n is equal to 2 divided by 0.01, why it become reversible? So log K goes this side, it will come down. Okay, this will come down, this will go up. So 1.1 into 2 divided by this, 1.1 is E naught of the cell, into 2 is number of electrons divided by 0.059. So what is the value of log K? Log K is so K is equal to antilog of this value, which is gives 1.941 into 10 to the power of 37. This is the B. B is the answer. Answer is B. So next sum is, calculate the standard cell potential of galvanic cell in which the following reaction takes place. Calculate the Gibbs free energy and the equilibrium constant of the reaction. Both they are asking, both the Gibbs free energy and the equilibrium constant. The reaction is given and some of the options also given. If Gibbs free energy, we need to know the formula of Gibbs free energy. Gibbs free energy is, what is that? Which is equal to Gibbs free energy is equal to minus NFE naught of the cell. Okay, N is the number of electrons, F is the Faraday's, and E naught of the cell is the cell potential. And here equilibrium constant, just now we saw the formula, E naught of the cell is equal to 0.059 divided by N log K. If you want to know the log K and the Gibbs free energy, what we need to know? First we need to know the E naught of the cell. If E naught of the cell is given, then it is directly we can go to that. If E naught of the cell is given or not, we need to check. No, it is not at all given. So we need to find the E naught of the cell. So E naught of the cell means E naught of the cathode minus E naught of the anode. E naught of the cathode here, this is the oxidation reaction, this is the reduction reaction. So oxidation is cathode reaction, oxidation is anode reaction, this is cathode reaction, reduction is cathode reaction. So we need to write the value of chromium and cadmium. First we need to write the cathode reaction value. Cadmium is minus 0.4, minus chromium is 0.74. So the value of 0.34 is the value of E naught of the value. And then this E naught we need to substitute in the Ecell. Number of electrons in this we need to find that also. See here in the balance equation, already they are given the balanced equation, so it's very easy. Whenever the electron is 3 plus, immediately you put over 3 over here. Then it balance 6 electrons. Then you need to balance here also, put 2 over here, and it is also 6 electrons. It's an easy method. Whenever here 3 plus electron is there, you put 3 over here, then it is easily balance it as a 6 electrons. So how many electrons accepts this cadmium? 6 electrons is accepts. So 6 electrons into Faraday's constant is 96500 into E naught of the cell is 0.34, which is equal to negative of 196.86 kilojoule per mole. This is the value. Okay, this is the value. And E naught of the cell is equal to, what is the equation? 0.059 divided by N log K. So substitute the N is equal to 6. Log K is equal to, go over here. So log K is equal to over here, and the E naught of the cell is 0.34 into N will be go here 6 divided by 0.059, which is equal to, if you balance it, you will get 34.5. So K is equal to anti-lag of 34.5. The value is equal to 3.192. What is the answer over here? 3.192. So 3.2. So answer is A. A is the answer. The next sum, I'm giving you some of the self-practice sum. So it's easy, you can try it, and the self-practice sum is also available at the end of this video. Just watch it. Thanks for watching.